We've seen how to load images into MATLAB, but how can we access the data inside images? Why is a color image stored as a 3D array even though images are two-dimensional? And how are movies, which are a sequence of images, stored? Let's answer these questions by starting with the grayscale image. Recall that a digital grayscale image is stored as a matrix of numbers, where each entry in the matrix represents the brightness of a pixel. We extract data from matrices by specifying the row and column indices of the data we want. For example, here we crop the image to contain only the man's face and camera by extracting a subset of the two-dimensional array. Color images, however, are stored as three-dimensional arrays because a red, green, and blue intensity value is needed for each pixel. Using red, green, and blue values, known as RGB values, is a common way of defining colors in digital images. Since the individual color components are represented by 2D arrays, we refer to them as color planes. Therefore, an RGB image has 3 color planes in the third dimension. How can we find the green intensity values of the image or crop a color image? In this example, the variable I stores the data for the digital image shown. Because I has 3 dimensions, we must specify indices for each of the 3 dimensions to access data in the image. Recall that we use a colon to represent all the elements of a particular dimension. Thus, this command returns all the rows and all the columns from the red color plane, which is the first color plane in the third dimension. Notice that the result is a matrix representing the red intensity values of the color image. Similarly, we obtain all the green and blue intensity values by specifying the second and third color plane in the 3D array respectively. What if we want to crop our image to remove the background? We still need to specify the indices for all 3 dimensions, but this time specify a vector of rows and a vector of columns for the first 2 dimensions. And since we still want a color image, we select all 3 color planes, using a colon to get all the data in the third dimension. The result is another 3D array, but with fewer rows and columns than our original image data. We are not limited to 3D arrays. Movies are 4D arrays, where the 4th dimension represents a color image at a different point in time. We refer to each image in the movie as a frame. To extract an individual frame from a movie, we need all the rows, all the columns, all the color planes, and the index of the specific frame we want. The result is a 3D array representing a color image. Try looking at the data in your own images. Remember that we need to specify indices for each dimension, thus 2 for grayscale images, 3 for color images, and 4 for color movies.